This is Unit 2, Topic 5, Probability Distributions. So far, we have been talking about distributions in a number of different ways. A distribution formally is a way to describe the outcomes of an event. And so far, we've looked at frequency distributions, and they were tables that we had made before a histogram, and they showed how often values occur over given intervals. We also had relative frequency distributions, which were the percentage equivalents. And then we talked about the normal distribution, which was a little bit different than the first two. And they showed how a histogram could be shaped in general if the bottom axis became a number line and the class widths became very, very small. In general, we had a bell-shaped curve over top of the normal distribution. So there's two major distributions that we're going to be talking about in statistics. There are discrete and continuous distributions. A discrete distribution is a distribution that models discrete data. So if you remember back to Unit 1, when we talked about discrete data, they were values that were limited. So for example, shoe sizes were only in whole numbers and half sizes, and then cylinders in a car are typically even numbers. Continuous distributions, they're distributions that model data where you can have any possible number over the interval. So this is actually what we were experiencing when we did a frequency distribution, because along the bottom axis was continuous because of a histogram's definition. In this topic, we are looking at just probability distributions. And a probability distribution shows all of the probabilities of the outcomes. So for every single outcome, we have a probability associated with that outcome. Because of this, they'll only work for discrete variables because we're looking at a probability for every single possible outcome. So this wouldn't work if we're looking at the weight of a soda can because we could have infinitely many decimal places if we had the ability to measure that accurately. One characteristic that is important with this is that since it is the probabilities for all outcomes, the probabilities must add up to 1, which would be 100% of the possible outcomes, or it can be extremely close, and this is usually depending on rounding. So if the value is off by a little bit, it should be because you had to choose to round somewhere, not because you left out one of your outcomes. So here are the instructions for finding the mean and standard deviation for a probability distribution in Stata. I'm going to skip that slide because we are going to do this together. One important consideration that we are going to make before we actually perform any calculations is that when you're describing probabilities for a population, that is what is going to be put into your table. So the mean and standard deviation that you find are going to be your population mean, mu, and your population standard deviation, sigma. And we've talked about these symbols previously, but this is one of the places where they're going to start to become important and necessary. So as we go forward, I would make a point to memorizing them as they start to reappear. So we have two exercises for this topic. Groups of 4 babies are randomly selected. In each group, the variable x is the number of babies with green eyes. Determine if the following represents a probability distribution. Explain why or why not. So first, the way that these are set up is almost always going to be the same. X is always your variable. And in this case, this is the number of babies with green eyes, and it looks like it's out of a total of 4 that we're looking at. P of x is just its function notation, and it's the probability of event x. So this is the probability that we have 0 babies with green eyes. This is the probability that we have 1 baby with green eyes, and so on. So reading this table is going to be pretty similar to anything else that you've read. So it's not any different just because you're, seeing it in your statistics class. So the question is this a probability distribution? If you remember on the intro slide to probability distributions, it has to describe all outcomes. So because of that, the probabilities need to add up to 1. They need to have 100% of the probabilities. Well, this is kind of a unique error because the probabilities actually go above 1. So 1.1 would be 110%, which is way too high. So when you add up all these probabilities and you get more than 1 and it's more farther off than this last decimal place, then you have a problem. So if this was 1.001, that wouldn't be off by very much, but just having one decimal place here means this would actually be 110%. So definitely way more than our outcomes. I would say it was a typo. The second example, Air America has a policy of routinely overbooking flights. The variable X represents the number of passengers who cannot be boarded because there are more passengers than seats. This is actually something that airlines do for almost every single flight. They overbook the flight because there's a certain chance that a person will not show. So this probability will change depending on if it's a holiday, if it's earlier in the week, if it's earlier in the day. I'm sure they have lots and lots of data collected because it's a business. They want to maximize their profit and they do lots and lots of interactions on a daily basis, weekly basis, and yearly basis. So this is something where there'd be a lot of data on. So determine if the following represents a probability distribution, explain why or why not. So one note to make is that if a probability is extremely small, and this is going to happen a lot as we go on into the course, we are going to represent it with the 0 plus. So basically what this means is you might have called this a machine zero or heard of that as well as machine zero. But this means that it's 0 if you have to eventually round somewhere. So if you rounded this to 10 decimal places, and maybe it still was 0, 0, 0, 0, 0, 0, 0. Maybe there's 50 zeros before you get to a non-zero digit. So this here would be representing it's not actually 0, but for the sake of calculations, we're going to consider it 0 because the value is just so small. So this is a probability distribution. If you added up all those values, they would end up giving you 1. Now note when I get to the 0 plus, in my calculator, I am putting it in as a 0. Sometimes people put in 0.01 or 0.001, but that's not the case because this is just a really small number. We have no idea how many zeros we have until we actually get to a non-zero digit. So every time you put one of these in your calculator, you are going to enter it in as just a 0. So the next few questions are going to involve reading this table here. So remember, X is the number of people that are unable to board because they've oversold, and P of X is the probability that this happens. So is it unusual to have 4 people that are unable to board? So there's not any calculations that you're going to need for this one because we already know the probability that exactly 4 people are unable to board is 0.187. So the probability that 4 people are unable to board is 0.187. Is this unusual is also one thing that the question asks about this. And if you remember, the cutoff for unusual for probabilities is 5%. So this is higher than 5% or 0.05, so this is not going to be an unusual probability. In my opinion, this is a little bit too high. The airline is going to have to find some way to accommodate for these people. So they're probably going to end up, I don't know, I would say having to make more arrangements than they would normally like to do. But I am not, a statistician for an airline. I'm sure that they have lots of data to make decisions like that on their own. Is it unusual for 5 people that are unable to board? So this should be 5 here. So the probability that 5 people are unable to board is actually 0.016. So the probability of this is 1.6%, which is unusual since the probability is less than 0.05. So this will need to be changed here. So what is the probability that at most 2 people are unable to board? So this is where we are going to combine some of the material that we had looked at in our probability sections. So at most 4 is 0, 1, or 2. I'm sorry, at most 2 is 0, 1, or 2. So that is going to be the probabilities of 0, 1, or 2 people. So this is probably what the airline is I'd say realistically looking to be willing to accommodate after this flight has been sold. So 46.6% chance that up to 2 people will have to, have other arrangements made for them because they've oversold the flight. So the next question says, here is the table for your output you get in Stata if you are finding your mean and standard deviation. So we're going to just break from the PowerPoint for a second and go through the Stata steps. Please do make sure that you are able to get this mean and standard deviation. And so then we're going to take the mean and standard deviation from the table and just practice using symbols as well as units along with that. So if we head over to Stata here, I do already have the data entered. So if you need help entering data, I would go back into one of the earlier PowerPoint slides or send me an email. So I have 2 variables here. The left one I've named unable to board, one word. So if you wanted to set this up so that you had a label come out with your output, you can edit your label row. So this is the number of people unable to board due to overselling. And then the second column here is the probability. Now, it's very important that you enter this here. In a mathematical sense, for the mean, it's not going to make a difference, but it will for the standard deviation. So you can never leave any of these off. So just make sure you enter the table as it's given to you. So now we're going to do something very similar to what we had done when we found the mean and standard deviation otherwise. So we're still going to follow the trail to get to, we're going to follow the summary statistics trail. So I'm going to keep going until I'm eventually able to select summary statistics. And so now what we're going to need to do is put our variable under variables with our unable to board people. You don't want that twice. The standard display will be okay in this case, so I'm just going to leave that. And then under weights, we want to select analytical weights, and then the probability column is going to be the weights that you want Stata to use. So when you hit OK, it's going to give you the same output that I have down here. And what we're going to need from this is the mean of 2.51 and the standard deviation of 1.25. So that is reflected on mu for the mean and sigma 1.3 for the standard deviation. Now note that I have a unit listed down here. It is very important that you have a unit every time. If you don't have a unit, it makes your number completely naked basically. So you want to make sure that you always have the number and what it's standing for along with it. So lastly, and this goes back to something that we did in Unit 1, it didn't make the exam. The reason for that is, first of all, there's a lot of information in Unit 1 that's way more important to us at that time. And secondly, because it appears again. So using the range rule of thumb, determine the maximum and minimum usual values. So if you remember, the range rule of thumb says that a value is unusual if it's more than 2 standard deviations above or below the mean. So you can set this up using a picture, kind of a number line sort of thing. I honestly prefer to just set it up in a formula, but it's because I'm pretty comfortable with this stuff. So I would suggest, along with this, having a number line with the mean in the middle and each step up being worth a standard deviation in distance. So the minimum usual is going to be 2 standard deviations below the mean, which is negative 0.09 people. So basically what this means is that there's no unusual amount of people to board on the low end. So if 0 people were unable to board, we wouldn't be surprised. And there can't be a negative number of people. Now, we do not round down because we're not saying that this has happened. We're saying this is just, we're describing the event. So we can have negative 0.09 people in this statement here. However, on the high end, there is a case, or maybe multiple cases, where we do have an unusual amount of people unable to board. So the standard deviation of 1.3, 2 above the mean, would be 5.11 people. And so again, don't round this, because if you round it to 5, you might have to say to yourself, well, I rounded to 5. Is 5 unusual or not? So I usually just choose to keep this in the middle, even though this is discrete data, because it will give you the ability to say, hey, okay, 5.11, that's a little bit above 5. So anything above 5, 6 for example, would be considered unusual. So this is a pretty short topic. What you'll find is that this week in general is more towards practice than it is to learning new concepts. And this is also a pretty short unit. So there will be a practice test that will go up with this week's material, and that is included in some of the time that you should be expected to putting into this course for the week. As always, please feel free to email me if you have any questions. And again, definitely make sure that you complete the practice test. The actual test will be very, very similar to it, so it will be the best way that you can practice.